Hi, my name is Campbell Davies, and I'm here to talk to you about the criteria in which planets need to meet in order to be able to support life, and then I will provide you with an example of my own that I've come up with. But first, we need to ask, what are the conditions required for life? The most important criteria is an energy source. That could be from the star that the planet is orbiting, or from geological activity located from within the planet. However, the presence of liquid water is also a very important criteria to be met. NASA has determined that the principal criteria of a planet in order to sustain life must have extended regions of liquid water, favourable conditions for the assembly of complex organic molecules, as well as an energy source to sustain the metabolisms of the organism. So these are the conditions that must be met in order for a planet to sustain life. However, this is not the bulk of it. There is many more factors in play here, and I will explore these factors throughout the rest of the video. Rather than having my planet just orbit a star, I thought it would be rather interesting if I designed a planet that was locked in an orbit with a large Jupiter-like gas giant that sits approximately 150 million kilometers from a G-type main sequence star that has a solar mass of 0.93 solar masses. This places the planet safely inside the habitable zone of this star. There are a few issues having a habitable planet orbit a gas giant. However, it is possible to support life if the gas giant does not interfere with the dynamic stability of the habitable zone, and if the orbit of the gas giant is within the habitable zone throughout its orbit. So in order for my planet to have a stable orbit, it needs to orbit the gas giant roughly around 1/9 that it takes the gas giant to orbit around its own star. So for example, if the gas giant took around 400 days to orbit its star, it would take my planet around 44.5 days to orbit the gas giant. So naturally, because my planet is orbiting another planet, my planet doesn't have any natural satellites, because they would fall into the orbit of the gas giant. So my planet will be mostly comprised of silicon rock, roughly 1.5 times the size of Earth. Now, if my planet was any smaller than Earth is, then it might not be able to support an atmosphere, as the gases in the outer layer will be stripped away from solar winds. Due to the location of my planet orbiting a large gas giant, my planet's surface will be subjected to a bombardment of extraterrestrial debris. This will litter my planet's surface with craters. This may be a possible source of origin of water for my planet. Now, the large bulk of water on my planet will probably be located within these craters, with possible links together through narrow channels as a result of weathering or as a result of tectonic activity. So most natural satellites are actually tidally locked to the planet that they are orbiting. Now this means that one side of the planet is exposed to sunlight for a longer period of time, and the other half of the planet is actually in complete darkness for quite some time. Now this will result in two very different temperatures ranging from either side of the planet. So my planet, in order to harvest life, my planet will actually have a rich carbon dioxide atmosphere with a pressure of about 1.25 bar. Not only does this allow a habitable condition for life to thrive here, it also increases the global temperature enough so that liquid water can be present on the dark side of the planet. Because my planet is tightly locked to the host planet, its rotation cannot contribute to the dynamo action that usually results in a magnetic field. However, there is another force at play that causes friction to heat up my planet's interior and keep the core molten. And this force is known as tidal heating. The tidal effects could also help my planet sustain plate tectonics, which in turn would cause volcanic activity to regulate my planet's temperature, and in turn create a geodynamic effect, which will result in a strong magnetic field. Now, a strong magnetic field is important for planets to harbour life because it provides a protection against stellar winds, radiation. Now that we have discussed the conditions that my planet have in order to sustain life, now the question can be asked, what kind of life is there? So life on my planet, as you can expect, wouldn't be overly complicated, and that is due to the high level of asteroid impacts as well as the rapid change in temperature that can happen on my planet. So because of these reasons, the life forms that we can expect on my planet will most likely be bacterial, and we can expect to find this bacterial life located near the hydrothermal vents located deep below the water. Now this is reinforced by the idea that the liquid water on my planet will only be located on the darker side and possibly towards the twilight areas. So for that reason, there's not going to be much sunlight. Therefore, the microbial communities located at these vents will have to find a different means of obtaining energy, and this could be due to carbon fixation. And the group of bacteria that my life forms would be most closely related to is that of chemolithotrophic bacteria. And with that, that's going to conclude my talk about what makes a planet habitable and an example of a planet I thought would be interesting to look at. So I think that's it, yeah? Oh, I haven't named the planet. I thought I forgot. Let's go with Uthia.